Now we take the second case, in which a particle is moving with uniform speed in a circular orbit of radius r under a central force which is inversely proportional to the nth power of r. So centripetal force required for uniform circular motion is mv square by r, where m is the mass of the body in circular motion, v is the speed, and r is the radius of the circular path. Because v is equal to omega r, so we can replace this v. We will have v m into omega r square by r, or we can write it as m into omega square r. This is equation number 1. This centripetal force is provided by the central force, which is proportional to 1 by r raised to the power, as it is given. So we can write this central force is equal to k into 1 by r raised to power n, where k is the proportionality constant. So equating this equation 1 and 2, because this central force acts as the centripetal force. So on equating, we will have that m omega square r is equal to k into 1 by r raised to power n, or omega square equal to k by m into 1 by r raised to power n plus 1. Omega is 2 pi by capital T, where T is the time period. Therefore, we can replace omega, and we have 2 pi by capital T square equal to k by m into 1 by r raised to power n plus 1. And now we can write T square equal to 4 pi square k by m by k into r raised to power n plus 1. This implies that T square is proportional to this 4 pi square m by k is a constant. So T square is proportional to r raised to power n plus 1, or also we can write T is proportional to r raised to the power n plus 1 by